Hello guys, welcome to my class. Today we are going to learn how to analyze seismic load on a multi-storied building. So at first open STAAD Pro, click on new project, click on space, you can give a name and choose a location. Length unit will be meter and force unit will be kilometer. Then click on next. Then click on add beam, then finish it. We are going to drawing the module or the structure by run structure wizard. For that, go to geometry, select run structure wizard, go to the model type, change it to frame model and select bayframe. For selecting the bayframe, double click on the bayframe. The length unit will be 16 meter and the norms will be 4. So the node to node distance will be 4 meter, the height 15 meter, norm of base will be 5, and the floor to floor distance will be 3 meter each. With 12 meter, norms 4 meter, and the node to node distance will be 3 meter. Again apply. And for we have our building. For merge it, then merge the structure to STAAD Pro. Click transfer model and yes and OK. The dimension will be 0 0 0 for x, y and z axis also. Switch off the snap node fluid. Now we have our building structure. Okay, go to the front view. Okay, go to, you have to support the column first. For that, go to support page, click here, go to create and select the fixed support, add it. Now select the support, okay, fixed support, and select the nodes of the columns. Go to isometric view, you can see that all the nodes are selected, and then click on the assign to selected nodes, then assign it and click yes. Now I have to give the beams or member property. Go to property page, click on define. It will be rectangle. For the column it will be 500 millimeter by 500 millimeter. In the meter is 0.5 by 0.5. Add it, and for the beams it will be 0.4 by 0.3 meter. Then add it and close it. Now first select the column property, and we are going to select the columns. For that we are going to go to select, go to beam parallel to y-axis for the columns, and select the assign to selected beams and click on assign, then click on yes for assigning the columns. Again select the beam property, then go to select, go to beam parallel to x and z for the beams are in the x and z axis. Then click on assign to selected beams and assign it, then click on yes. Now our property has been given. You can check by 3D render view. See, all the properties are given. If any property leave mistaken, give the property in the structure, you can view it here. Okay, close it. Now to give the load. For the seismic load, you have to remember that the seismic load will come first. If you apply the wind load, live load, dead load, seismic load at a one time, and you should remember that the seismic load will always come first. So we have to give the seismic load first. So now go to load page, or you can go to the commands, go to loading, go to definition, go to seismic load. Okay, now you can choose the IS code, your code. I am going to select 1893 2002. This is here 1893 2002. Okay, now click on generate, and you have to choose the city where the structure will build. Okay, you can choose a city or you can choose the zone if you have the information which city is on the which zone. Okay, I'm going to select a zone, and in our zone is 3. Okay, you can choose the special RC moment building, or you can see ordinary RC moment building, OMRF. Important all building or important building. You can see the factor is change. Okay, I'm going to select important building. You have to select the soil, and for that you have to know what is your soil property. Okay, now select medium soil, and we are going to design RC frame. Change the damping ratio to 0.05. Okay, foundation depth is 3 meter, and click on generate. Okay, then add it. Then close it. Now click on the zone. We add the property. Now select that property and click on add. Now click on self weight. Now click on add. Select the self weight. Now select the member weight. Now the weight will be 20 kilonewton. Click on add, and the floor weight is 3. Now you have to define the ranges. For the X ranges, it will be on the X plane where the distance. You see, this is the X plane, so we have to know the distance. It is 16 meter. We have to know the first point to last point. Okay, it is in the X, it is 0, and for that it is 16, and for the minimum is 0 and maximum is 16. Similarly, in the Y range, the minimum is 0 in the Y range, and the maximum is 15. Okay, so minimum 0, maximum 15. In Z range, this is Z range. Select minimum 0 and maximum is here is 12. Then add it. I'm just selecting 3 for the whole structure. You can select the multi room or roof. Okay, terrace roof 2.5, or for the rest of the floors is 3. Okay, then after finished, click on add. Now all the things are applied except the weight. Now select the weight. Now select all the beams of the structure. For that, go to select, go to beam parallel to X, and select beam parallel to Z. Now click on assign to selected beams and assign it, then yes. Now all our conditions are assigned. Now we are going to add live load and dead load. For that, go to load case detail, click on add, loading type. Oh, at first we have to add wind load and seismic load. Okay, go to seismic. Where is seismic? And seismic, give title seismic. Okay, it is on the X direction. Okay, so at first copy this thing. This will be easy for you, and it will be in X direction. So click on select, press X, then add it. Again seismic title, I'm going to copy the seismic and then paste the seismic. This is shortcut. Okay, it will then minus x for understanding you, paste it in then z direction, z, add, then minus z, add it. Okay, now seismic x, select seismic x, select add. Now go to seismic, in the x direction, factor 1, add it. Again seismic minus x, click on add, go to seismic x direction, it will be minus 1 for the minus x direction, rest will be default. Then click on add, then close it. Seismic z, add, go to seismic loads in the z direction, factor is 1, add it, close it. Now go to seismic minus z, select seismic minus z, select add, go to seismic load in the z direction, minus z for minus 1, then add it, close it. Now our seismic loads are given, then you have to give the dead load, live load. For that, go to load case detail, click on add, click on dead load, dead, give title, add it, and live, add, close. Now select dead load, click on add. In the dead load, it goes self weight, add, goes member load. In the members, load will be minus 16.5 in the x direction, so minus in the global y direction, then add it. And the floor load, okay, it will be minus 5 kilonewton. And the we have to define the y range. For that, minimum is float is minimum float in the 3 meter, and maximum is y direction in the 15 meter. So minimum 3, maximum 15, then add it and close it. Now go to self weight, it goes in the whole structure, so we are going to select assign to view. In assign, then yes, then member load, select member load, go to where to select the members. For that, go to select beam parallel to x and z. Now click on assign to selected beams and assign it, then yes. After that, go to live load, okay, add it. In the live load, it goes only the floor loads, minus 2 kilonewton, widening is same, 3 to 15, then add it, close. Now we have add the total loads. Now we have to combine the loads. For that, go to combines, loading, load combination. For seismic load, the factor will be 1.2. okay, we are going to add it by live date seismic x. Again live date seismic minus x, live date seismic z, live date seismic minus z. Okay, so you can give the title for understanding. Live load for LL plus dead load DL plus seismic load ACI. Okay, 1.2. Now select live date and seismic x. Now have to give title seismic x. Selecting the available loads by pressing Ctrl from your keyboard. Now name is live load, dead load, seismic x, and we have selected the live date and seismic x. default 1.2, and for now click this for selecting the loads, then add it. Okay, again live load plus dead load plus seismic, then space. Now copy the name for it will be easy for you. Okay, it is shortcut for engineers. Then direction -x, default will be same. Now select the same live date -x by pressing Ctrl from your keyboard. Now select that for selecting, then add it. Now paste our name and it will be Z, seismic Z. So select live date and seismic Z, then select and add. Now again paste the name in the -z, -z, select live date and -z and select, then add it. Now we will select all the loads, then close it. Now we have our combined load. Okay, now we have to analyze it. Go to command analyze, perform analyze, okay, analyze, run analyze, save. You can see there is no error, but there is one warning. Okay. Go to view output file. That is the warning. Okay, analyze it. In each case, we follow performance and change. Okay, it is nothing. You can ignore it. Just close it. Now go to post processing. Select all the combination load with seismic loads. Okay, go to axial load, reaction for the columns. Now select 4 columns. For that, go to top view, select 4 columns by node cursor, go to view and view selected object only. Go to isometric view. Now select text. Now select, move the reaction table. Now what we have to do is select the loads. Now for seismic X, focus on the Y. How is change? For seismic X, it is -119.319. For seismic -x, it is positive. Seismic Z, it is negative. Seismic -z, it is positive. Dead load 513, live load 32, and for combination load, you see this is change 511.781. This will same for the rest one. Then 798 it is increasing, then 467 decreasing, 842. Now see, this is the worst case of the for that column. So we have to need that value, the worst case of the column. Okay, that is the purpose of combination load combination. Okay, now for the whole structure, the reaction is different, and we have to note down the each and every column reaction and for the worst cases, and we have to design on based on that load. Okay, then it will be a economical design. Okay, now go to display whole structure. You can check the animation, deflection, apply. Okay, you see that it is moving different in the different loads. It is, see, escape from it. And check the beam bending. Okay, you can check the axial force for the columns. Okay. Shear force in the y direction, in the z direction, shear force, bend torsion. Okay, you can change, you can have the torsion in the what you select the load. Okay, it change beam stresses, change the traces, it will change the diagram. You can have the graphs for beam, for columns, select column. You can have the graph for column, select the beam, it will show the beam, and graph for beams. Okay, so if you want to design the structure, then go to design, go to modeling, design, then concrete design, then select your code, select the parameters, and now design it. Okay, it is very easy, and that's it. That's how you analyze the seismic load in the STAAD Pro on multi-story building, and you can design also in the, because in the previous session we learned how to design. Okay, so that's it, and keep subscribing on my channel. Okay, so thank you for watching my video.